Hello, welcome. Let's try to solve some mathematical problem. 2614, prime in diagonal. So for this problem, we are given a matrix. So that is the nums. So it is a 2D matrix. So the rows equal to the column. So according to here, we can say the nums length is going to equal to nums i's length. So this means it's going to be a square. And we just need to find all the diagonal numbers. So we have two diagonals. So this is the main diagonal. Yeah, let me use another drawing. So this is the main diagonal. This is the another diagonal. So we just need to check all those numbers, and we're gonna return the maximum prime number. So for each of the number, we need to check if this number is a prime number, and then we're gonna find the maximum. And in the first example, the maximum prime number is 11, so we're gonna return 11. I think we can start to write the coding directly. Yeah, because we just need to check if a number is a prime number or not. So I'm gonna use n to represent the length of the nums. So as the row equal to the column, so we're gonna check it directly. I'm gonna prepare a result because if we didn't find it, we're gonna return a 0. So I'm gonna prepare a result to be 0, and finally I'm gonna return the result. So for I in range n, I'm gonna check one by one. So I'm gonna write a function to check if this number is a prime number or not. So it's prime. Let me put inside maybe a number n. And currently I will give a pass because definitely this is gonna be easier to write if we were to check if a number is a prime or not. Yeah. So if it's prime with this number I. Yeah, but it is not I. It is the nums I and I. So if it is prime, we're gonna check the maximum value, and this value gonna be the nums I and I. Yeah. So this number is definitely inside of the diagonal. So if it's prime, another one, it is the nums I with n minus 1 minus I, and we should know the formula. Because I with n minus 1 minus I, it is in the sub-diagonal. It is this one, yeah. And I is going to be the main diagonal. It's going to be this one, yeah. And we should know where is the main diagonal and where is another diagonal, yeah. Yeah, if it is like that, we're going to update the final result. It's going to be the result with this number. And finally, we're gonna return the result. Now let's just finish writing the prime number check. Yeah. So for I in range from 2, and we should know how to write it. So the integer of square root of this number plus a 1. If n modular I equal to 0, so definitely it is a false. Otherwise it's going to be true, but we have to check this number must be more than and equal to 2. Otherwise, if we didn't check 0 and 1, we will think maybe, yeah, for 0 and 1 maybe it is a prime number. Actually it is not, so we have to check this number going to be more than and equal to 2. Now let me just submit it to check if it works. As you can see, it works. Now let me just submit it. Yeah, as you can see, it works, and it's pretty fast. And let's analyze the time complexity. So for here, for the time complexity, this is just a for loop. This is the length of the nums array. So this is 300, okay. And here we're going to have is prime check. So for the is prime check, it is the square root of n. So the time complexity of n times square root of n. Yeah, so this is going to be the time complexity. As we can see, this is going to be a really not n. This is going to be, let's use another number, maybe. Yeah, let me just try to use another color. So it is n times the square root of maybe capital N. So capital N is going to be 10 to the power of 6. So this is a 10 to the power of 3, and this is a 300. So it seems 3 times 10 to the power of 5. So this is going to be the final time complexity. As you can see, definitely it works in Leetcode. So what about we just write it in another way? So this is easier to check. So what about if we just write the acytosis algorithm? That going to be a little bit hard, but that can be used to solve more Leetcode problems. Yeah. So here I'm going to use E prime, but because I don't know the acytosis, that how to pronounce or how to write that word, that is too difficult for me. So I'm going to use E prime. So that's going to be the acytosis algorithm to solve the problem. Yeah. So from here, yeah, let me just prepare the code. So from here, I'm going to prepare a primes array. So it's going to be the fourth times 2 plus 2 times n minus 1. And from here, we're going to prepare the primes going to equal to, we're going to call the function, call this E prime. And the maximum number going to be this number, 4 times 10 to the power of 6 plus 1. So yeah, so we don't need 2 plus 1 actually. Yeah, because this number, this n is inclusive for the algorithm. So we don't need to unprepare that. Yeah, so this means we're going to prepare an array. The length of the array is going to be this number. And we can check the is prime in just O1 time. So if we ignore these areas, the time complexity is going to be On. As we can see, definitely we're going to reduce the time. Yeah, but for this problem, actually the time complexity is this number. Yeah, it is all this number. But actually for us, while we are running the algorithm, we can ignore this because this one just runs one time in Leetcode, and this one just runs many times. It depended on how many testing cases. Yeah, so we're going to write it in this way. Yeah, now let's just write it from here. So for I in range, from here we're gonna set it to n plus 1, and we're gonna have a check if primes I. This means if this number primes I is a prime number, what are we gonna do? Yeah, we're going to use another loop. So for j in range I times I n plus 1 to I. Yeah, I think you need to remember, definitely you need to remember this kind of algorithm. And you also need to understand it, why we're going to write it like that. Otherwise, maybe you cannot remember. So for example, if 2 is a prime number, right? So we're going to start in from 4. So 4 is not a prime number. And to the end of this number, 6, 8, all those numbers we're gonna set it as not a prime number. So from the beginning we're gonna set it as prime number. Now it is not. So this is this kind of algorithm we're gonna call it acytosis algorithm. Yeah, this is a really good to solve such kind of a prime number problem. Yeah, and then we can set it. So primes j gonna equal to false definitely. And finally we're going to return the primes. Then we're going to call this function from outside of the class. We're going to call this function and get the prime numbers array, and in this one we're going to check it directly. So from here we're going to check it directly. As this is an array, we're going to turn this into array, not function. So from here we're going to use the array to represent this number. We're going to check it something O1 time from here. Yeah, I think that's all about it. Let me just run it. As you can see, it works. Now let me just submit it to check. As you can see, it works, and it's pretty fast because it beat 100% of all submissions, because this is a better solution. So the time complexity is going to be the maximum of it's going to be the maximum of n. N is the length of the array, and the maximum of this number, n is this number, 4 times 10 to the power of 6. Yeah, it depended on which number is bigger. But definitely this is like a linear time complexity, and it is better. I think that's all about it. Thanks for watching. See you next time.